సార్ నేను అది లాగిన్ అయ్యి చేశాను, అది కనిపిస్తుందని చూడండి ఒకసారి. అదే నా పీపీటీ నేను ఇక్కడ నుంచి ఆపరేట్ చేశాను, ఒకసారి మీరు.
గుడ్ మార్నింగ్ సార్.
గుడ్ మార్నింగ్ సార్.
గుడ్ మార్నింగ్ సార్. కనిపిస్తుంది సార్ మీ పీపీటీ.
ఓకే,
మీరు కనిపిస్తున్నారు, పీపీటీ కూడా కనిపిస్తుంది సార్ క్లియర్ గా.
థ్యాంక్ యూ.
ఓకే ఓకే సార్.
నో ప్రాబ్లం కదా సార్, వాయిస్ క్లియర్ గా ఉంది?
వాయిస్ కూడా క్లియర్ గా ఉంది సార్, వాయిస్ క్లియర్ ఉంది. కెమెరా సెటప్ మీరు కొద్దిగా పైకి పెడితే కొద్దిగా అంటే యాంగిల్ బాగుంటుంది అని అనుకుంటున్నాను అంతే సార్. కొద్దిగా కెమెరా పైకి లేదు సార్, మీ ల్యాప్టాప్ లో చెప్తే ప్రాబ్లం ఇది, ఆ ల్యాప్టాప్ లో అయితే అంతే సార్, ఇంకేం చేయలేం కానీ.
ఓకే సార్, ఇప్పుడు ఓకే.
ఇది ఇంటరాక్టివ్ గా బాగుంటుంది సార్. థ్యాంక్ యూ సార్.
ఓకే, థ్యాంక్ యూ సార్. మెసేజెస్ వస్తాయి. బీటెక్ అదే అన్ని లెటర్స్ ఉంటాయి. ఫోన్ నెంబర్ అంతే ఉంది. ఫోన్ నెంబర్లో లెటర్స్ ఉంటే నెంబర్స్ ఉంటాయి, లేకపోతే మనం యాడ్ చేసుకోవాలి. యాడ్ నెంబర్ ఉంటుంది, క్యాపిటల్స్ అవి కొంచెం మేనేజ్ చేసుకుంటాం.
మీరు జాయిన్ అయిపోయి ఉండండి అలాగే.
కనిపిస్తుంది.
ఆఫ్ చేస్తాను నేను వీడియో.
ఎందుకు?
ఇప్పుడు వెళ్ళని ఎక్స్ప్లెనేషన్ నేను. నీ కెమెరా వచ్చి చేపెట్టాను రాలేదు. నాకు వచ్చి కెమెరా మీద చేపెడితే రాదు. హలో.
కొంచెం అనిపిస్తుంది స్పీకర్
స్పీకర్స్ అనిపించకుండా వినిపిస్తుందా?
అనిపిస్తుంది నాకు.
పెద్దగా ఉంది.
పెద్దగా మీరు వస్తారు
వాళ్ళకి కనిపించడం చేయట్లేదు.
చేంజ్ అవుతుంది అసలు.
చేంజ్ కూడా కట్టలేనా? లాస్ట్
బ్రహ్మయ్య సార్, బ్రహ్మయ్య సార్, హలో సార్.
గుడ్ మార్నింగ్ సార్. సార్ బ్రహ్మయ్య సార్ లేరు సార్, చెప్పండి సార్.
స్లైడ్ మోడ్ లోనే ఉందా? లేదు, అదే మన స్క్రీన్ పెద్దగానే వస్తుంది కదా?
ఆ స్క్రీన్ పెద్దగానే వస్తుంది సార్.
ఓకే.
అంటే మీరు స్లైడ్ మోడ్ లో లేదు సార్, అంటే పక్కన పీపీటీస్ కనిపిస్తున్నాయి, పేజ్ 1 పేజ్ 2 అలా.
స్లైడ్ మోడ్ లో పెట్టాను సార్ నేను, అంటే పెద్ద స్క్రీన్.
ఇలా అయినా పర్లేదు సార్, ఎందుకంటే పిన్ చేసుకుంటే సరిపోతుంది, క్లియర్గా ఉంటుంది పార్టిసిపెంట్స్ కి.
అవునా?
ఇక్కడైతే ఎలా కనిపిస్తుంది అంటే మీరు జనరల్ గా పీపీటీ ఓపెన్ చేసినట్టు కనిపిస్తుంది, స్లైడ్ మోడ్ లో అయితే కనపడట్లేదు. Yes.
అంటే స్లైడ్ మోడ్
మొత్తం ఒకటే వచ్చేసి
అది క్లిక్ చేయండి సార్.
అది క్లిక్ చేయండి సార్.
ఇప్పుడు సార్?
లేదు సార్, అలాగే ఉంది, ఏం చేంజ్ లేదు సార్.
అవునా?
మనం క్లిక్ చేయలేము సార్.
స్లైడ్ ఏం చేంజ్ అవ్వట్లేదా?
స్లైడ్ చేంజ్ అవుతుంది సార్, కాకపోతే స్లైడ్ మోడ్ లో లేదు, స్లైడ్ చేంజ్ అవుతుంది సార్.
ఒక్క నిమిషం
మళ్ళీ ఇది అవుతాను. ఓకే. సార్ ఇప్పుడు సార్
స్క్రీన్ విజిబుల్ లేదు సార్ మీది.
లేదా?
నాట్ షేరింగ్ ద స్క్రీన్ సార్, ప్లీజ్ షేర్ ద స్క్రీన్.
క్లోజ్ చేసి
అది కొడితే రావట్లేదంట సార్, మనకి ఇలానే కనిపిస్తుంది, అలా స్లైడ్ మోడ్ పెట్టినా కానీ. స్లైడ్ షో లాస్ట్ సార్, స్లైడ్ షో సార్ అదే క్లిక్ చేశారు, కాకపోతే ఇక్కడ మైక్రోసాఫ్ట్ సపోర్ట్ చేయట్లేదేమో అయి ఉండొచ్చు.
ఇప్పుడు సార్?
Yes sir.
Yes sir.
Sir, shall we start the session, sir?
Yes sir, yes sir, yes.
Good morning participants. Here I hereby invite Divya madam to introduce our speaker for this particular session, morning session. Divya madam, proceed.
Yes sir. Good morning sir. Am I audible to you clearly sir?
Yes ma'am, yes ma'am.
Yeah, okay. A very good morning to one and all. It's very great pleasure to introduce our speaker, Dr. B. Mangu, sir. Dr. B. Mangu is a professor in the Department of Electrical Engineering under University College of Engineering, Osmania University, Hyderabad. He received his BE and ME degrees from Osmania University, University College of Engineering, Hyderabad. He was awarded PhD degree in the Department of Electrical Engineering at IIT Bombay. He has 19 years of experience in the area of electrical engineering. His areas of interest include renewable energy sources and power electronics. He has published 25 papers in the international conferences and in IEEE transactions also. Professor B. Mangu is the principal investigator for 2 research projects funded by DST PERS and promotion of university research and scientific excellence and technical educational quality improvement program. He has conducted global initiative for the academic network course titled with high voltage gain short switching advances current fed technologies for microgrid and electric transportation, which is sponsored by Ministry of Human Resources Development, Government of India. And he is an active member of IEEE Power Electronics Society, IEEE Power and Energy Society, IEEE Industrial Electronic Society and IEEE Industry Application Society. And he has served in Osmania University College of Engineering under various capacities like head of the department and chairperson board of studies and faculty advisor and hostel warden, and at present he is serving as nodal officer TEQIP. He is a member of Board of Studies in Electrical Engineering, JNTU, Hyderabad. He has delivered several expert lectures at different platforms in the area of electrical engineering with more than 19 years of teaching experience and research experience. He is guiding 8 PhD scholars in the area of design of power electronic converters for integration courses, and he has visited many countries like United States of America and Canada, etc., and he presented research papers in international conferences too. So thank you, sir. I am inviting you to deliver your great lecture for participants, sir. Thank you very much, sir.
So thank you, Divya madam, for introducing me to the
Thank you, sir.
And thank you, Brahmaya sir, and all the faculty of electrical engineering and the management of St. Peter's Engineering College for giving me this opportunity. So thank you. So now I'll start my presentation. So my voice is clear?
Yes, sir.
Yes. So my presentation is grid integration of renewable energy sources. These are the outlines of my presentation. First, I'll give some introduction about the renewable sources. And then I'll move to power evacuation technologies and MPPT tracking methods, standalone system and grid connected systems, and the issues with the grid integrations. Okay, the types of the grids. So these are the outline of my talk today's. See, if you compare the traditional the power grid with today's power grid, main difference is now the share of the renewable energy sources is increased. Now, if you see this one, so what is the issue in that? If you integrate renewable source to this one, so if you integrate renewable sources to the grid, it have both positive consequence as well as negative consequence. Okay, so means what? While integrating renewable source to the grid, so there are some challenges, some issues that we have to address. So here basically I'll start from the scratch. So, and then I'll move to the step by step. So what are the challenges? Okay. So what is the issues in today's grid, power grid, with the traditional grid? So what is the difference, or what are the issues that we have to face, that I will highlight. Okay, so here if you see that conventional grid or traditional grid, power grid, so there is centralized power generation, and if you see the distribution feeder, so we have load. That distribution feeder is what you can consider as a passive circuit. Okay, but here now as the share of these renewable energy sources to the grid increases, so what are the issues arise that we have to concentrate? Okay, and how to means if the share of PV or that wind or renewable energy source increases, that some penetration issues problem, so that will arise, and how to address those issues. See, actually this topic is very good for those who are doing PhD or that research scholars. Okay, so here there are so many issues are there, that issues we have to address. Okay, so that issues I will highlight, but I will start from the basics. Okay, so, as you know, these are the key renewable energy sources. Okay, so among these key renewable energy sources, now if you see this one, the share of PV and wind sources dominating. So means among these renewable sources, the strong contender is PV. After that, it comes to the wind source. Okay, Now, so here I'll mainly focus on what are the issues with this grid connection of this PV source as well as this wind source. So what are the issues issues arise and how to address those issues, that I will highlight. Yeah. Now, if you see this one, if you take any renewable sources, the means it will generate either AC or DC. Means the source is the type of source is either AC or DC. But load also it is a AC or DC. But here, see, you have to understand the issues. So we cannot connect renewable sources directly to the load. Okay. So in this, we require the one interface circuit. Okay, one interface circuit. I'll give an example because I know English or I know Telugu. Okay, so you know English. So here is what we have to communicate between the each other. So in that is what to communicate each other, we require a translator. So like that, here the need of power electronics is very much essential to communicate between the renewable sources and the load, because load is AC, it may be AC or DC, and your renewable source also it may be AC or DC. So now to interact with the load with this renewable source, we require a interface circuit. So here interface circuit is power electronic converter. So power electronic converter plays a major role. Okay. So and yeah, so that is the importance of this interface circuit. And if you see the RE renewable source integration or interfacing. So now if you see the either PV source or fuel source, that you have to connect to the AC grid. Okay. Now if you see this one, the load and this one, but see, you cannot connect PV source or fuel source directly to the AC bus. So what, because PV source is DC, so you cannot connect to the AC bus. So we require one interface circuit. That interface circuit is what which converts DC to AC. So in similarly, fuel cell also is a DC source. So that also means to interface this fuel cells with the AC bus, we require a converter. So means what, that is the importance of that interface circuit. Now to highlight this one, I have shown this figure. So battery is DC, and if you take the wind, so wind source. So even though wind source is a AC source, but you cannot directly connect it to the that AC bus bar, because wind source gives a variable frequency, because you know the frequency and voltage are the two important parameter for the power grid. So means what now means these are the means to interface any renewable source with the power grid, we require a interface circuit, that is power electronic converters. That may be a DC-DC converter, DC AC or AC DC. Okay. So now the importance of power electronic converters is, so it contributes a lot for the power conversion of renewable power to conventional uses, and power conversion technologies are undergoing many changes for quality of power. So for this, so you should know the knowledge of DC-DC conversion, DC-AC conversion, and DC-AC, DC to AC, AC to DC conversion. Okay. So and understanding the behavior of source, sink, passive element, filters, control methods plays a major role in this conversion. So now I'll move to that power evacuation strategies from solar photovoltaic energy systems. Yeah. So and as you know, this fuel cell is the basic building block for solar photovoltaic, but single solar cell is not sufficient for power demand or power requirement. So these cells are is either connected, means they are connected both in series and parallel to increase the voltage and current, so that the power is what increase. So this is a solar module. So finally is what these modules is what either they connected in series and panel. So that is called a solar array. So now the solar photovoltaic source means we have, that is solar array is the main component for this one. But here thing is, if you integrate solar to that solar photovoltaic or that wind source to the grid, okay, normally is what the strength of the grid that depends on the this one thing is what where we are connecting this where we are integrating these renewable sources. So this strength of grid is what that is decided by the SCR. SCR means short circuit ratio. Okay, so means normally the uh, the short circuit ratio means fault level capacity. So fault level capacity of that bus, it should be high so that it should not disrupt, even though under that short circuit fault, that bus should observe that one and it should not disrupt to the other system. So that is the importance of that SCR, short circuit ratio. So normally is what for strong grid, the SCR, the short circuit ratio, it should be more than 10. So this is with respect to the integration of renewable sources. So please try to understand. So I am talking with respect to the integration of renewable sources. So means what, how much short circuit ratio you need to integrate your renewables for the grid. So minimum short circuit ratio, that is where we are connected, that is called a point of common coupling. So at PCC, the short circuit ratio it should be more than 10. If it is less than 10 means, or it is less than 5, under that circumstance we cannot connect or we cannot integrate renewable source to that grid. So these are the some issues are there. Okay, normally is what, depending on the capacity, either will connect or will integrate renewable source, either distribution level or that transmission level. Okay, but normally is what, mostly if you see now, mostly is what all renewable sources are integrating at 11 kV bus bar, that is the distribution level. But the issue is the H by R ratio for a this distribution level, it is very less. That is hardly, it is I think 1 point, not 1.5, it is means less than 10. Okay, less than 10. So here is what means, it comes under a weak grid. So means what, these are the issues. Means normally is what X by not X by R, short circuit level, that is SCR, that should be, it should be more than 10. So that you have to make ensure. And coming to the this either we are connect distribution or transmission level, the X by R ratio, if you take the HV transmission line, the X by R ratio is more, it is 16. But coming to this distribution level, the X by R ratio is 1.5, this is very less. So normally, now what is the importance of X by R ratio? See, if X by R ratio is more, then the voltage variation, that is voltage means the voltage maintain almost constant. X by R ratio is less means what, there is a voltage variation, voltage fluctuation is there. So like that, there are so many issues are there. That issues you have to try to understand, and you have to think how to overcome those issues. Okay, so means what, every problem, see, first is what, so I am telling to the faculty or research scholars. So first and foremost thing is, you have to understand what are the issues. First thing is what, you have to understand what are the issues with a conventional grid. So now, because see, now we are moving to grid, smart grid, all this one. Now thing is what, you have to understand, okay, understand what are the issues. If you understand the issues, then you make those issues as a problem for your research and formulate that as a problem, and you try to, okay, address those issues. Then you will get a good paper in any transactions like that. So like that you have to do the research. So first and foremost is you have to understand the reason. So in conventional system, if you see this one, okay, normally is what, distribution feeder. One side we have generation, and feeder. This is just like a passive element. But now with the renewable energy sources, if you integrate renewable sources at the feeder level, see, conventional grid is a one way, but with renewable sources, if you see this one, because means power flow in a reverse direction also. So there are means protection issues are there. There are so many issues are there. Like that, you have to understand X by R ratio while integrating. What are the things you have to see? So means what normally is what the point of common coupling, where the means the grid should be is what it should be strong. Means strong means what the capacity, that is short circuit ratio capacity, means it should be high. There only you can integrate, then it will not cause any problems. But for weak grid, if you connect these renewable sources, then you have to face so many issues. Okay. So now, I will discuss while that grid penetration comes. Now, if you see the PV source, now everybody knows this module, solar panel, and that solar panel is what will connect to the grid. But here, so this is what PV equivalence, that one cell, how the mathematical model of the PV cell. Okay. So this is this. So already you know, I no need to tell all this one. So here, if you see the cell IV characteristics and PV characteristics. So here, okay. So it looks simple, but you have to try to understand the main concept. So here, if you see the IV characteristics, the behavior of the PV source. So as voltage increases, the current is almost constant. So means what can we, so in this region, can we consider PV source as a constant current source? Yes, obviously. Okay. But here, as in this region, as voltage increases, see, there is a drastic decrease in the current. Okay. So that means what in this region means, in this region, can we consider PV source as a voltage source, because voltage variation is less in this region and current variation is less in this region. So now if you see the power versus voltage characteristics, as voltage across the panel increases, power also increasing. So it is reaching the maximum point. After that, even though voltage is increased, the power is decreasing. Okay, why? Because see, as voltage increases, there is a drastic decrease in current. Because of that, the power is decreasing. So this is the PV characteristics of your power and voltage characteristics of your PV source. Okay. Now, if you see these characteristics, so there is only a one point where your panel is what delivers the maximum power. So means what? Here you have to ensure that your operating point, it should be at MPP. Then only we could extract the maximum power from the PV source. Suppose your operating point is before the MPPT or after the MPPT, you could not extract, even though power is available in the panel, you could not extract the maximum power from the PV source. So means what? This is the issue. So here is what, even though your operating point is away from the MPP point, what you have to do is you have to bring that operating point to the MPP point, then you can extract the maximum power. Okay. Then I'll discuss how to means bring the operating point from some other point to the MPP point. So what are the method you have to adapt, that we will discuss. So here PV source is what, there is only one point, and here if you see in next slide, yeah. So see, try to understand this one. So here is what means the IV characteristics depends on what parameter. Now if you see the first this graph, or first graph, here if you see this one, the power output from the solar, that depends on the radiation. So here as radiation increases, the power output from the panel also increasing. Okay. Now see, your power output from the panel not only depending on the solar radiation, it also depends on the ambience condition of the cell. Now if you see the temperature, see, as temperature increases, see, power is decreasing. See, normally we will think that if I install in solar power plant in Rajasthan, I may get more power, but that is not the condition. So because if you see this one, as temperature is increased, see, temperature increase, the power output from the panel is decreasing. And one more thing is, say as voltage is increased, temperature is increased, voltage across the panel is decreasing. You can see this one. Voltage across the panel is decreasing. Means the relation between the ambient temperature or cell temperature with the power is voltage is what it is inversely proportional. But here if you see this one, as radiation increases, current also increasing, but variation in the voltage is less. Means what? The impact of radiation is more on the change in current rather than on the change in the voltage. Okay. So this is the current and voltage characteristic with temperature. Now if you see the impact of temperature is more on voltage rather than on the current. You can see that the variation in current is less. Means the impact of temperature is less on the change in current. It is more on the change in voltage. This is the panel voltage. Yeah. But here if you see this one, the change in current, change in radiation is means impact is more on the current than voltage. Okay, means what? So as in radiation increases, current increases, but variation in voltage is less. Okay, so these are the main things about the IV character. Because see, we are using solar means what? You have to understand thoroughly the behavior of solar source, how and what parameter it depends. So that you have to understand. Yeah. And one more thing is what? See, everybody knows. Okay. So what is our goal? So what is the need for MPPT? Okay. So why we are not able to extract maximum power under all conditions? So the only thing is, say what we have studied in our circuits. So it's a simple concept. To extract maximum power from any source, it has to obey the maximum power transfer theorem. So already we have studied this one. So what maximum power transfer theorem says is, to extract the maximum power from any source, its load impedance, it should be equal to the source internal impedance. If both the load impedance and the source internal impedance matches, under that condition only you can able to extract the maximum power. That we know. So same concept we are using here, that maximum power transfer theorem. Okay. Now if you see this one, so solar that array is directly connected to load. But here thing is, see the operating point is what? Intersection of the source characteristics as well as the load. Suppose here, suppose I have connected a load that is okay, for understanding I have considered the resistance load. That load I have considered is what? The 7.2 ohm I have considered. And this is my IV source characteristics, and this is the load characteristics. Okay. Now operating point is the intersection of the source characteristics and the load characteristics. Okay. So here if you see this one, okay. So under this, with this load, my MPP point means PV source is what? It will give maximum power at this point, but now my operating point is here. So means what does it mean? Okay, even though maximum power is available in the solar array, because of mismatch in the operating point, we could not extract the maximum power. Okay, because operating point is what? It is lying away from the MPP point. Okay, please, it looks simple, but try to understand the issue here. Okay, so means what? With this 7.2 ohm, I could not extract the maximum power from the PV source. Okay, then what I have to do? If I connect solar panel directly to the load, so what I have to do to bring the operating point to MPP point? What I have to do? I have to increase the load. But as an electrical engineer, can I vary the consumer load or customer load? No. Is it in our control? No. Okay. So please try to understand the issue. So means what? Load is not our control. See, based on the load demand, our generation we have to either increase or decrease. So means what? Always our load demand generation and the load demand has to meet. But here, if you see this one, okay, to extract the maximum power from my source, I cannot vary the load, and I cannot tell the consumers or customer that please increase the load or decrease the load, because see that load the load is what that depends on the consumer's wish or customer's wish. So we cannot dictate them. Based on their requirement, we have to supply. But issue is what here, to extract the maximum power from the solar, you have to vary the load. So practically is what it is not possible. So this is the issue. Okay, then how to address this issue? Means what, without varying the load. Okay, and we have to extract the maximum power from the PV source. Means we have to obey the maximum power transfer theorem. And also just now we have seen the IV characteristic. Means the PV power is what, it is not a, just like not a constant DC source. It is a variable source as well as intermittent. Means the power output from the source is a function of solar radiation as well as temperature. Okay, it is not a just like a DC source, constant DC source. Okay. So here is what means what the internal impedance of the source is what, it is always changing. And to extract the maximum power, your load impedance has to match with the internal impedance of the source. But thing is what here, the problem is you cannot vary the load impedance to match with the source impedance. Okay. So this is the issue. Then, okay, how to address that issue, that we'll see. Here, see, to bring the operating point to MPP, you have to vary the load. Okay, that is one solution, but it is not, you cannot vary the load. Okay, and with the temperature also it is varying, that already we have seen. So this is the issue. Now, to address this issue, we need one interface circuit between the PV source and the load. Now, what is the role of this interface circuit? See, means what? Without changing load means changing means what? You cannot vary the load. So means what? These parameters is not our control. This load is not our control. But to satisfy the maximum power transfer theorem, your load impedance should be equal to the source internal impedance. This power converter, that is DC-DC converter or interface circuit, has to dynamically match the load impedance with the source impedance without varying the load impedance. No, this DC-DC converter is nothing but we are calling as a MPPT converter, because the role of this DC-DC converter is it will match the load impedance with the source impedance. Okay, load impedance with the source impedance, so that we can extract the maximum power from the PV. Okay, so means what here, that is means the importance of electrical engineering is what. Okay, otherwise, see, if you see this one, if there is no the role of this power electronic converter, then now where is the question of the role of electrical engineer in this means renewable source integration? Now it comes to the maybe mechanical engineer, all this one. So now without power electronic converter, you could from the PV source to this one. See, don't confuse with that mechanical tracking with the electrical tracking. So this what we are discussing is electrical tracking. See, mechanical tracking is what? So you know the intensity of light, it should be perpendicular to the surface. Means as sun moves from east to that west. So means what? You have to rotate the panel. Means you have to ensure that the panel always perpendicular to the radiation or the rays from the sun. So that is the mechanical tracking. See, that is different. See, mechanical tracking is different, but electrical tracking, this is, so that is called a maximum power point tracking. Means here what we are doing is what we are making with the help of this power electronic interface circuit, we are making load impedance equal to the source impedance. So means what, this DC-DC converter vary the resistance seen by the panel such that just now we have seen, means what, will vary the the resistance, see, we are not varying the load. Please remember, we are controlling the duty cycle of the DC-DC converter such that the resistance seen by the module, okay, means the effective resistance seen by the module is equal to the internal impedance of the source. If both are matches, then under that condition, our maximum power transfer theorem obeys, and under that condition, you can extract the maximum power from this one. So that is why we require a MPPT. That is the need of MPPT. So for extracting maximum power, definitely you need a power electronic converter. Without power electronic converter, you could not extract the maximum power. That is the role of this interface circuit or that power electronic converter. So here, for this doing this job, we require a DC-DC converter. Okay. So this DC-DC converter is what? It will match the load impedance with the source impedance, because here the problem is source impedance variable and load also variable. So this interface circuit is what always it will try to match the load impedance with the source impedance so that we could extract the maximum power from the source. So that is the importance of this MPPT converter. Yeah. Now if you do the power balance of DC-DC converter, the resistance panel that equal to, so there is a means if you derive this one, R by D square. So this Ri is what? The resistance seen by the panel here. See, Vs by S, this is, so means what? The resistance means the see, R is the load. R is the load. We are not varying the load resistance, but the effective resistance seen by panel, that is a function of load resistance as well as D square. Now here one thing you have to understand that this R is what you cannot vary. Okay, because see, we don't have control over this one. This means what? This load depends on what? That customer wish or that consumer wish. But we have the duty cycle. So here if you see this one, by varying the duty cycle, we can vary the resistance. So means what? If resistance is variable means what? By varying this D square without varying the actual load, we are varying the resistance seen by the panel, and we'll match this resistance seen by the panel with the internal impedance of the source. If both are matches, under that condition you can extract the maximum power. So that is the philosophy or logic behind this MPPT tracking. Okay. So I hope you have understand this concept. And one more thing is what normally is what okay, we'll means that we'll use two terminals. One is MPPT converter, other one is MPPT charge controller. See, so these are the mostly we'll hear these terminology: MPPT charge controller, MPPT converter, MPPT charge controller. So MPPT charge controller means, see here the load is battery and source is PV source. So MPPT charge controller means what? Here you have to understand that your load is battery, but battery plays means it is a very sensitive element. Okay, and already you know, so battery is what it will have a nominal voltage. Suppose normally in market 12 volts battery is available, so that is the nominal voltage. Means you can charge that battery. Okay, so there is a upper voltage limit and there is a lower voltage limit. Means what? Within those limits only you have to operate the battery. Otherwise, battery will get damaged. And you know, the lifetime of the battery that depends on the charging and the discharging cycle. Okay, so means what? If you go on overcharging the battery more than its float voltage, means battery get damaged. So means what? You cannot overcharge the battery as well as you cannot over discharge the battery also. If you over discharge the battery, what happens? Your battery get dead. So means what? The safe operation of battery is means you have to use the battery within those limits, upper voltage limit and the lower voltage limit. Okay, that is float voltage and the what is that? Yeah, I didn't remember that see, maximum is float voltage will call, and actually depth of discharge, but one term I didn't remember. So lower voltage cutoff and the upper one. Within that limit only you have to charge the battery. But here, see, if you see this one, this is the PV source and this DC-DC converter. Then why we have used DC-DC converter? To extract the maximum power from the PV source. Now we have of freedom, that is the duty cycle. So with 1 degree of freedom, you cannot extract the maximum power as well as you can protect the battery at a time, because you have only 1 degree of freedom. Either you can extract the maximum power from the PV source, or you can protect the battery from over discharge or overcharge. Yeah. So here, so means what, only we have one duty cycle, 1 degree of freedom. So means what, here you have to understand that MPPT charge controller means what? So means what, here the two functions you cannot achieve simultaneously. But first thing is what, here we have to, means we need one more parameter, that is the, what is the state of charge of the battery. So normally is what SOC will call state of charge of battery, and will sense that the battery voltage. If battery voltage is not reached the float voltage, that is upper cutoff voltage, that means what, your battery is what, it is able to take the energy. Okay, so here see, battery is what, it will act like a source as well as it will act like a sink. Okay, so both function, whereas PV source is what, it will act like a only source. So here if you see this battery, so it will act like a source as well as sink. But here the limit is what, it cannot store the energy beyond its limit. Okay, so means what we have to ensure is, if battery is overcharged, means it reached the upper cutoff voltage, under that condition you cannot extract the maximum power from the PV source. Why? See, this DC-DC converter is what, its role is what, always it will extract the maximum power from the PV source, where it will dump that power into the power into the battery. But battery is what, already fully charged, and this converter is what, it won't see the load. What is the condition of this battery? This converter is what, go on extracting maximum power, and it is dumping that power into the battery, means it is charging the battery. But battery is already charged. So under that condition is what, you cannot extract the maximum power. Okay, so means what, now you have to change the role. So now instead of extracting maximum power from the PV, now you have to is what, you have to protect the battery. See, now extracting the maximum power is not essential for us. Why? Because now battery is what, it is not able to absorb that excess power, because battery is already, it is in fully charged. So under that case is what, rather than extracting maximum power from the PV source, you have to protect the battery. Okay, means what, you have to, here the role of this DC-DC converter is, instead of regulating the panel voltage, it has to regulate that output voltage. Means, see, that is why I told you we have only 1 degree of freedom. So using this duty cycle, either you can control the input voltage. Input voltage is same as the PV panel voltage, whereas output voltage is the battery voltage. So means what, using this duty cycle, either you can control the voltage across the panel. What is the need of controlling the voltage across the panel? So just now I have explained, if voltage across the panel equal to VMPP, then you can extract the maximum power. So using duty cycle, what we are ensuring is, the voltage across the panel, we are keeping that equal to VMPP. VMPP means a voltage corresponding to maximum power point. Suppose the panel voltage by somehow, if you maintain that voltage equal to your VMPP voltage, means voltage corresponding to maximum power point, then you can extract the maximum power. But here is what, using D, either you can regulate this voltage or battery voltage. But using this D, simultaneously you cannot voltage this voltage or input voltage and the output voltage. See, PV voltage is the input voltage and battery voltage is the output voltage. only one work we can do, because we have only 1 degree of freedom. Either you can control the output voltage or the voltage across the panel. Okay. See, for extracting maximum power is what we have to control the voltage across the panel equal to VMPP. For protecting the battery, you have to regulate, or you have to control the voltage of the battery that equal to the float voltage, that is the maximum voltage limit. Otherwise, if you charge, then battery will get damaged. So, okay, I hope you have understood this concept. So means what, that is called a battery. So MPPT charge controller. So MPPT means it is doing the MPPT as well as charge controller. See, charge controller term is related to battery and MPPT term is related to the source. Okay, so they have combined this one. So MPPT charge controller. Okay, so means what it is do, means based on the battery voltage, it is extracting maximum power from the PV source. When battery voltage reaches to upper cutoff voltage, under that case, it is protected, means we have to protect the battery from overcharging. So means what, now you have to, the role of DC-DC converter has to change. Means instead of regulating the input voltage, now it has to regulate the output voltage. Okay, so this is the need of that MPPT and the battery charge controller. Yeah. And already you see, thing is, there are so many MPPT techniques are there. So one, the basic method is perturb and observe, and the other one, the hill climbing and incremental conductance is there. So here simple, I'll see this, all these control algorithm developed based on the PV characteristics. Now if you see these PV characteristics, see here, as voltage increases, power also increasing, and it is reaching this one. And here, and this is called a MPP point, and we have only one MPP point. So here, after MPP point, as voltage increases, power is decreasing. Now we'll use this concept. So because we know from the PV, from our fundamental concept, so if the PV characteristics means what, for some range, a certain range, as voltage increases, power also increasing, and for some range, as voltage increases, power is decreasing. And the intersection of these is these two regions, that is constant current region and constant voltage region, that is your MPP point. So we'll use this concept, and finally is what we'll reach to this MPP point. This one here, I have shown that arrow. So means what, means now to reach the MPP point, one thing is what, we need two parameters. Means what, we need to see one, if I have one power level, I have two operating point. One is before MPP, other one is this after MPP point. But here, so first is what, you have to identify whether you are before MPP or after MPP. Suppose your operating point is before MPP. So please try to understand, your operating point is what, before MPP. Now what is our ultimate goal? We have to reach to the MPP point. Yeah, we have to reach to this. So then what we have to do, we'll increase the array voltage, and we'll see whether power is increasing or not. Like that, we'll go on increasing array voltage, and we'll see we'll observe. So this is perturb, means we'll disturb and we'll observe. So this is the first algorithm. And once we reach this one, after, because we don't know whether we have reached MPP or we don't know. Means how do we know? Because we'll increase the voltage. Suppose if power decreases, means what? Yeah, we have crossed the maximum power point. Under that condition is what, we will decrease the voltage. So this is the concept we will use for all this one. This perturb and hill climbing. Just a hill climbing means what, this looks like a hill. So we have to climb to this peak point, is that is our MPP point. So we are calling it a hill climbing. So, okay. So here is what, see, don't confuse, the concept is same. See, one is means which concept we are using. One is what, one parameter is what we are using, array voltage, to reach this one, because either we are increasing array voltage or decreasing array voltage, and we'll observe the power. So this is called a perturb and observe. Okay. Hill climbing is what, see, the variable parameter is duty cycle. See, ultimately is what, to vary the input or output, we have to vary the duty cycle. So based on their, what is the parameter they are controlling, they have given the name. in perturb and observe, we are varying the voltage. In hill climbing, we are varying the duty cycle. That's all. Means duty cycle is the controlling parameter. In perturb and observe, voltage is the controlling parameter. And in incremental conductance, see, instead of measuring the voltage across the panel or duty cycle, what they are measuring is what? See, they are using the one more concept, that is the slope. So this is a one line. See, if you see, this one is a positive slope and negative slope, and here at peak point, if you see this one, you know, from maxima and minima, at peak point the slope, that is dp by dv equal to 0. So they have used that concept and they have given one name, that is the incremental conductance. So that's all, but ultimately concept is same. If you use P&O or hill climbing, ultimate goal is what? You have to reach to this peak point. So this is about the MPP and the need of MPPT and this concept. Yeah. So means what? Here without DC-DC converter, you cannot achieve the maximum power point tracking. See, just now I told you, for perturb and observe, they have used the voltage reference, and this is the actual voltage and PI controller, and they will generating the duty cycle. Based on this, they are generating the duty cycle. But here in hill climbing, instead of voltage, they have used the parameter is what? Duty cycle. So it means controlling parameter is duty cycle. So they have given the hill climbing. Yeah. Already I have discussed in incremental conductance. See, dp by dv greater than 0 means what? Positive slope is what? Before MPP, means left of the MPP. If dp by dv is less than 0, that is the right of MPP. So like that. So if you make di by d equal to I by v, see, this is in the form of conductance. So that is, they have given the incremental conductance. Okay. So this is about the MPPT techniques. Yeah. Okay. Now coming to the standalone system. See, standalone means what? Standalone. See, by name itself, standalone means what? Normally is what? See, our we are depending on the conventional is what? We are depending means where we are tapping the power from the grid. Here standalone means what? We are not taking the help of grid. Okay, so standalone system means we are taking the help of renewable sources. So load is what? AC load or DC load. So based on this one. Now, if you see this one, standalone system means what? Suppose load is AC. Okay, so load is AC. Suppose household appliance, if you see in remote places, now load is AC, but source is what? It's a DC. Okay, now load is AC, my source is DC. Now how to interface AC load with the DC source? So for that is what I need a interface circuit. What interface circuit I require? Because from our fundamental, from see, already we have studied the so many converters. So which converter converts DC to AC? You know, inverter. Okay, so here is what we require a inverter, the DC to AC, to connect the AC load. But in addition, so inverter is not sufficient. So in addition to inverter, we require a one DC-DC converter. Now already I have explained the role of the DC-DC converter is what? To extract the maximum power. Okay. Now to extract the maximum power, what it will do? It will match the load impedance with that effective load impedance with the source impedance. So means what? To extract the maximum power, you require a DC-DC converter, and to convert the DC to AC, you require an inverter. So means what? Now to process the power from the DC PV source to the load, how many converters you need? We need two converters. One is DC-DC converter. So here the role of DC-DC converter is what? See, it won't see anything. What it will do is it will match the load impedance with the source impedance. Its job is it will match the load impedance with the source impedance. That's all. Because if load impedance is matched with the source impedance, then your source obviously will deliver a maximum power. Now this inverter is what? Because load is AC, this inverter is what? And here load is AC. AC means what? Already you know, across the load. Okay, because all loads are designed for, see, all single phase loads are designed for 230 volt RMS voltage and 50 Hz frequency. Now this role of this inverter is it has to regulate the voltage. Means what? Once it will regulate the voltage equal to its nominal voltage, then based on the impedance of that load, it will take the power. So now role of this inverter is what? It has to ensure that the voltage across the load is 230 volt RMS, because all our load is designed for a 230 volt RMS. Now 230 RMS means what? Its peak value is 325. So means what? Load means you have to generate, means this inverter, the role of this inverter is what? It has to generate a sinusoidal voltage, because all our load is designed for a sinusoidal voltage. Okay, so the role of inverter, see, input is DC, load requires a sinusoidal waveform or sinusoidal. So the role of inverter is what? It has to, from DC, that is constant DC, it has to generate a sinusoidal AC waveform whose peak is 325. If peak is 325 means what? RMS voltage is 230 volt or 230. Okay, so means the job of inverter is what? It has to regulate the AC voltage to 230 volts, as well as it has to generate a sinusoidal waveform. So that is the role of this inverter. Whereas the role of this DC-DC converter is, it has to match the load impedance with the source impedance. Means its role is always extract the maximum, whatever maximum power available in the solar panel. So that is the role of DC-DC converter and the inverter. Okay, but now if you see this one, so what is the drawback of this standalone system? Okay, suppose, see, now suppose same this configuring if I use for household appliance. So normally is what? We'll use night time, but solar, do you think solar is available night time? Okay, now see, this is the issue, because see, solar is available in daytime, but load is what? Night time. So now this is the issue. Means what? This circuit you cannot use for meeting the nighttime loads. Okay, so means what? Now you understand the issue. Then what you have to do? You have to do some modification such that nighttime also we can supply power to the load. So what modification we have to do? That you have to think. So now you understand the, because see, suppose load is what? Nighttime load, we have to operate in nighttime, but source is available in the daytime. So under that condition is what? You cannot meet the load demand in the nighttime. So what is the solution here? So means what? You require a, okay, means apart from the solar array, you have to use one more source. Okay, or not only source, means you have to use a source as well as sink, because this source is not available night time. So means what? Whatever that extra component which we'll use, means it should act like a source during the night time, and during the daytime it has to act like a sink. Because see, sink means what? Now you tell me, what is the element which play the double role or dual role? Means what? Source as sink. See, in electrical engineering, only there are two elements which behave like a dual role. One is battery, other one is the grid. See, grid is what? It plays, means it acts like a dual role. Means what? It will act like a source as well as sink. See, sink means what? It will, see, grid is the means what? It is a just like a battery only. It will store the energy whatever amount, means infinity power it can store, and it can deliver the infinity amount of power, just like a ocean. Whereas battery, it is a limited source, and the sink means what? Limited means what? It cannot store the energy infinity, and it cannot deliver the energy to the deliver the infinity energy. So means what? That is the constraint of the battery. But whereas grid, okay, whereas the grid, it can act like infinity source as well as sink. So that is why, see, 75% of the PV source, they are connected to the grid. Standalone system is what? It is for remote applications, very less. See, compared to standalone system, if you see this one, grid connected system is what? So in a PV market, if you see, 75% of the PV market is what? Grid connected system only. Okay, only 25% is what standalone system. Okay, so but the standalone system is what it is. We can use standalone system where the grid is what not means use of grid is not a viable solution in remote places. Okay, there you can go for the standalone system. Okay, but here is what suppose see now if you observe share of the renewable sources what day by day it is increasing. Which component increases? Grid connected only. Okay, compared to standalone, grid connected is what because we have a large panel and means and we are directly connected to the grid. Okay, so that is the grid connected system. So later we'll discuss. But here see one by one I am coming. So standalone system means what? Where grid option is not viable solution. So here is what totally this will depend on the renewable sources and the energy storage element. So now my question is, so here in this so what is the application of this one? Where do you use this one? For pumping applications. See, for pumping applications, you can use the solar array to the that water pumping application because night time that water pumping that is what is a daytime load. Night time we don't require. So this configuration there you can use, but in household appliance you cannot use this one. So we need a one energy storage element. Okay, so normally is what battery we are using. So there are so many energy storage elements are there, but in the market the available is what battery. So we'll use the battery as the energy storage element. So means what in standalone system. Okay, so standalone system is what in standalone system definitely we require a energy storage element, that is a battery. Okay, so means what here battery plays the major role. So means what means whenever solar is available, the battery has to store some energy, and during the night time it has to deliver to the load. So question is, where do we connect that battery? Either you see battery, you know, it is a DC, but here if you see this one, we have two DC that DC bus bars. One is what output voltage, other one is the PV voltage. So shall I connect battery to across the PV, or shall I connect that battery to across the this DC link voltage? DC link voltage means input to the inverter. Okay, and here one thing is what I cannot connect a battery directly to the DC link voltage because see to get the 325 my DC link voltage it should be 400 because see, you know the DC link voltage, okay, it should be more than the my AC voltage peak value. See AC voltage peak value is 325. So means what my input to the inverter it should be more than the 325 means I can use 350 to 400 volts. But as a thumb rule, generally the DC link voltage of the inverter is what we'll use the 400 volts. Okay, so that is a DC link voltage you are require 400 volts. Okay, now where shall I connect that battery? Because this voltage battery now see to get the if I connect directly battery to here, so means what I have to connect so many batteries in series because see my DC link voltage is 400. See 12 volt battery. So means what you require so many batteries. Okay, 400 by 12 volts. Now you can calculate how many batteries you need. So like that means here. See you have to think the different what do you call cost point of view also and the feasibility where shall I connect so that my overall efficiency of the system should be better. Say as an electrical engineer, our main aim is efficiency. Okay, so means how to improve the efficiency of the system. Okay. So means what in standalone system, I require a energy storage element that is either battery or ultra capacitor. See for on-grid system, okay, means in normally is one in grid connected system, we won't use the means for higher power capacity we won't use the battery as storage, but for critical loads there we'll use even though grid connected system we'll use the battery just like in home we are using the inverters. Okay, so just like a backup storage during the blackout, that is UPS operation, but normally in grid connected system we won't prefer the that energy storage element, but in a standalone system definitely you have to use the storage, that energy storage element. Okay. And one more thing is what on grid connected system also, for revenue generation, what they will do is just they store the means when solar power is available, they store energy in the battery. Okay, and suppose load is peak load, under peak load condition, then whatever peak load condition will take power from the battery. Okay, so that say in peak load the tariff is more. So for revenue means tariff, this we are not using, but in USA, America, it is using. They are using this one. They are using large battery they store, and under peak load, they will sell power with higher tariff. So like that. So see, I am highlighting the importance of energy storage. Where do you use this one? Okay, for off-grid system, RE source output varies, and you know renewable energy source is what? It is an intermittent source. So output power is means output power from the renewable source is a variable. So now for that definitely we require intermediate storage to supply the constant load. Okay. So sudden peak load demand supplied by the energy. So means what, this battery will come into picture whenever there is a peak load demand, means sudden demand is there, because PV source it cannot give the instantaneously. Okay, because if the power output from this depends on the solar radiation. But here, if I use the battery, suppose my load is increased, then I can take power from the battery. Suppose PV is generating more power than the load demand, so means what, is excess power, your battery will take that excess power and it will store. Okay, so that is the role of the energy storage element. Okay. So normal is what, and one more thing is what, see, the power flow from the battery, it should be bidirectional, because battery is what, sometimes it act like a source and sometimes it act like a sink. So for that means what, power flow, it should be bidirectional, means what, you cannot use the unidirectional converter. So for interfacing the battery with the standalone system, you need a bidirectional DC-DC converter. Okay, so here, so if you see this one, so means what, for battery we need a bidirectional converter. For MPPT tracking we need a one more DC-DC converter. If load is AC, we need a inverter. So means what, overall you require 3 converters. One is bidirectional DC-DC converter for battery interfacing, and we require one DC-DC converter exclusively for MPPT tracking, that is for impedance matching. Okay, and if load is AC, you require one more inverter. So means what, in standalone system, overall we require three converters. So here is what, see, yeah, bidirectional converter means what, see, based on the requirement, suppose if excess power in the, see, our ultimate goal is what, always you have to ensure that your generation is equal to the load demand. Suppose if your generation is more, load demand is less, means in a system there is a excess power. So who has to observe that excess power? The battery has to come into picture and it will take that excess power. Suppose load demand is increased, but PV generation is an intermittent source, PV is generating less power than the demand. Under that case, what, battery has to come into picture, and battery, it has to supply that efficient power in the system. So see, normally is what, people will think that battery will use only night time. No, the battery plays a very important role, just like a grid. Okay, so means what, it will maintain the system balance. If battery is not there, then a standalone system won't work, because see, there is no balance between the load demand and the generation. So battery is what, battery is a very crucial, it will play a very crucial role to make the system under balanced condition. So means what, if deficient power is there, it will supply, if excess power is there, it will absorb. Okay, but
excuse me, Mangu sir.
Tell me, sir.
Sorry for the interruption. A wonderful lecture related to the topic related on standalone system, challenges and solutions related to the standalone system. As per the schedule, we are supposed to have a break at 11 a.m. sir. So with your permission, we would like to announce a break of 15 minutes. Yes, sir.
Okay, sir. Sure.
Yes. I request all the participants to take a break of 15 minutes. We will resume the session at 12 sorry, at 11:20. I request all the participants to take a break of 15 minutes and we are going to resume the session at 11:20.
కంఫర్టబుల్ ఉంది అక్కడ చెప్పడం అక్కడ చెప్పడం అనేది మంచిగా ఉంటుంది. వాయిస్ క్లియర్ సార్ వాయిస్ ఇప్పుడు స్ట్రక్
కృష్ణ అందరికి వినిపిస్తుంది.
Excuse Mangu sir.
Sir.
Sir, thank you for the break, sir. We would like you to continue with the lectures.
Okay, sir. Thank you, sir.
Thank you, sir.
Sir, my slide is visible, sir?
Yes, sir, it is visible, but it is not in the slide mode, sir. Slideshow mode.
Okay.
Yes, sir. Now it is visible in the full screen mode, sir.
Okay, sir.
Okay,
So
sir.
shall I continue, sir?
Yes, sir. Yes, sir. You can continue the lecture.
So this is about the standalone system. So I'll concentrate more on that grid renewable energy penetration issues. So this is different means configuration for standalone system. This is for battery interfacing, and this is PV interfacing, and the load if voltage source converter, that is inverter we are using for connecting. Yeah. Yeah. So here main challenge in standalone system is what as number of power stages is more, so efficiency will come down. So you can do research in how to reduce the number of stages so that efficiency is improved. So that is only the challenging task in this standalone system. Other one is the that control strategy. So control strategy is what you have to see. You have to operate in all the modes. That is MPPT mode means MPPT means what? Always MPPT means extracting maximum power from PV source. Non-MPPT mode means what? Depending on the load, whatever power you require from the PV source, you can extract. That is the non-MPPT mode. Shutdown mode means what? Okay, battery mode. So battery mode means what? Nighttime PV is not available. So entire load demand is you have to meet using this battery. Shutdown mode means what? Because battery is a limited source. It cannot give the whatever energy you require. So means what? If battery is reached to lower voltage limit, under that case is what already I told. You cannot discharge the battery less than your lower limit. Otherwise the battery will get dead. Okay, so that is called a shutdown mode. Means there is no option. So you have to shut down the system. So that is about the control strategy of the standalone system. Yeah. Now coming to the grid connected system. Okay. So you require a grid means what? PV source you have to connect it to grid. So PV is a DC and grid is AC. But here one thing you have to understand that grid is a stiff source. Means what? In standalone system you have to using your inverter you have to regulate your output voltage. But here thing is what? Because grid is a infinite source and their voltage and frequency are two parameters, and voltage is a stiff source. Means what? Voltage using our PV inverter you cannot regulate the voltage. So means what? Here what we have to do to inject the power into the grid, only thing is what? You have to inject the current into the grid, and the injected current you have to ensure that it is in phase with that grid voltage. So means what? Always you have to make ensure that the power factor is unity. Means indirectly is what? You are injecting only active power, not reactive power. Okay. So now to get the shape of grid voltage, you require a PLL. So here that phase lock loop, that is just like for synchronizing generator, synchronization purpose. Here PLL is what? That is used for synchronizing your PV source with the grid. So here actually grid connect, there are so many research topics is there in grid connected system. Okay, so here first I will highlight what are the issues I will highlight, and then I will give this. Okay, or my scholar will give because he is doing research on this grid connected that mitigation and penetration issues of solar PV. So he will explain. But here, what is the scope in grid connected, that I will highlight. Okay. So already I told as the share of the renewable sources increases. So we have both the positive consequence as well as negative consequence. Here we have to means there are so many issues are there that we have to tackle. Okay. Now already that one thing is in a conventional grid. Okay, we have their generator means moving part, but here PV source is what? We don't have rotating component in this one. So means what? Inertia, because some energy is stored in that inertia, because it's a synchronous generator is a movable part. So kinetic, that half mv square, some energy is stored. So means whatever that energy that is utilized, suppose load demand is suddenly increased, the what means kinetic energy that is utilized and to compensate this one. But here if the share of the PV source increased, see PV source is what? There is no inertia because there is no moving parts in the PV source. And PV source is what? It cannot instantaneously increase its power or decrease its power. So that is the limitation with the PV source. So means what? PV source is a inertialess, whereas your conventional generator, they will have a inertia, more inertia. So that is also one of the very important topic, because the frequency that frequency depends on the fluctuation in the frequency, that depends on the how the load is matching with the generation. So so here that so how we have to overcome that issue, that my student will explain you. So means what are the method, how to tackle that method. Now you understand the issue. No, in conventional grid we have a inertia, but coming to the PV source we don't have inertia, because that is a it is a rotating, so it will have a kinetic energy. But PV source is what it is a there is no movable part. So there is no inertia in this one. But how to overcome that frequency fluctuation. And one more thing is what that see the voltage that voltage stability of any power grid, that depends on the reactive power generation, means the reactive power mismatch. It leads to the instability of the voltage. So means what, in a transmission line already you have studied, there is a surge impedance loading. Means what, transmission line will represent the transmission line using resistance and the inductance and the capacitance, but long transmission line will neglect the resistance. So L and C, and as per our knowledge, capacitor will generate the reactive power and inductor will absorb the reactive power. So in there is a sag and a swell in. So the main reason is what, mismatch in the reactive power generation by the inductive element and the capacitive element. So that is the main reason for the voltage sag and swell. Okay, and because of sag and swell, there is a variation in voltage. But here, if you see the any renewable sources, so what it will do is what, whenever there is a over voltage or lower voltage, the sag or swell, then immediately is why the PV source is what disconnected. See here, if sharing of the PV source is more, if this condition happens, so then what happens, active power is what, it is decreased. Okay, because now share of PV power is what, more. Okay, so means what, here suppose share of the PV power is less, under that case is what, grid will take care of all this. But suppose if PV share of the PV source is more than the conventional thermal power plant conventional sources, under that case is what, if there is any sag or swell, under that condition is what, your PV will disconnected. And then there is a means what, active power is what, suddenly it becomes zero. So that is one issue. And other one is what, because there we have a turbine governor system, but that is not there in here. So like that, there are so many issues are there. So, and one more thing is what, that reactive power compensation. Using PV source, you can compensate the reactive power, but the control strategy is different here. So that also I will highlight. And so here, see, main thing is what, in grid connected system. So this is inverter and this is your grid. Okay. See, same thing is whatever transmission we have analyzed or we have learned in power system, same concept here. See, using your inverter, we are generating AC voltage, and this is your grid voltage. In between you have to use the inductor, just a transmission line model. This is one bus voltage and this is the other bus voltage. Now to transfer the active power from one bus to other, to transfer the reactive power from one bus to other. So these two concepts are very, very important, because to transfer the active power from this bus to that bus, so always see, active power flows from leading angle to the lagging angle. Okay, so here grid will take the reference, and this the inverter output voltage V0, it should lead to transfer the active power from the inverter to the grid. So what you have to ensure is the inverter output voltage that should lead the grid voltage. Then only active power will transfer, and the amount of active power is already this is just like the transmission line model. So input voltage, output voltage by the that impedance of the inductor, that is omega 1. Omega 1 means what, we are considering only the fundamental component, L into sin theta. So active power is what, it is directly proportional to the angle difference between the grid voltage and inverter output voltage. So this is about the transfer of the active voltage. So coming to the reactive power. So reactive power is what to transfer the reactive power. First thing is what you have to make the phase angle difference between your inverter output voltage and the grid voltage should be 0. See, if angle is there, then active power will flow. So to supply only reactive power, first thing is what you have to make the phase angle between your inverter output voltage and grid voltage, it should be 0, so that there is no active power flow. Now to flow the reactive power, what you have to do is, see, please remember, reactive power always flows from higher voltage magnitude to the lower voltage magnitude. See, these concepts are very, very important. One is what, for flow of the active power from one bus to other bus, what you have to do is you have to create the phase angle. Because active power flow, the amount of active power flow, that depends on the phase angle between the grid voltage and the your inverter output voltage. And for reactive power, so what you have to do is, the phase angle is 0, and if you increase the magnitude of your inverter output voltage more than this one, then it will supply the active power. Suppose to observe the reactive power, what you have to do is, your inverter output voltage magnitude should be less than the magnitude of the grid voltage. Then it will take the reactive. Like that, you can do the reactive power compensation also. And both active power, reactive power, you can compensate at a time. So there is no problem in this one. So here is what you have to try to understand the concept. To transfer the active power, what parameter you have to change. To transfer the reactive power, what parameter you have to change. Okay. So here, if you represent the equivalent circuit, see, Vs is grid is what is will take always a reference, and this is your inverter output voltage, just like transmission line model. Say theta means what? Now it is leading the grid voltage by theta angle. So based on the theta, your active power will flow. Yeah. So that is a control, this one. Now here normal is what, in grid connected system, what we'll do is, because see, it is a 325 volts. Suppose you are connected to that single phase. Suppose your PV voltage is less, under that case is what, you can use the low frequency transformer, that is 50 hertz frequency transformer. See, here is what you have to see, what is the pros and cons. If I use the high frequency transformer, low frequency transformer, the size is more, but advantage is what, it will provide isolation between the grid and this one. So isolation purpose it is better, but in size point of view, this is a bulky system, and here we require one DC-DC converter for MPPT, and inverter is what, converting DC to the AC. Okay, so these are basics. Means this is called a single stage grid connected system. So here, see, we have not used the DC-DC converter for MPPT tracking, but that MPPT algorithm is what, using inverter, means inverter, the DC link voltage we are going to see here, DC link voltage same as the PV output voltage. So here MPPT algorithm we have used we are doing use by sensing the DC link voltage. So DC link voltage is same as the PV voltage. Okay, but here what is the drawback here? Because your PV voltage, you should be equal to the 400 because we are using high frequency transformer, so it may be less than that 400 volts. Okay, so this is about the single stage grid connected system. Coming to the two stage grid connected system, so we are using DC-DC converter for MPPT tracking, and we are using inverter for injecting power into the grid. So this is about this one. So next, my scholar will discuss the issues of solar power. That is, see, voltage. See, the voltage fluctuation is there, and islanding problem, and reactive power flow. All this active power, because see, already you know, if there is a passing cloud is there, suppose share of PV source is more. If there is a passing cloud is there on that panel, then active power is what suddenly become to 0. So under that case is what your there is a instability in the grid. So the means the entire stress is on the conventional the thermal power generators. So these are the issues. So, and islanding problem means what? See, islanding means what? Because we have a renewable sources. Suppose grid is disconnected, means what? Using that renewable sources, it will form like a one system. It will operate at a different frequency, and grid is now, suppose circuit breaker is again closed. Now grid will have a different frequency, and this islanding system will have different frequency. Then if I connect, then there is a very means it's a big problem because different frequencies, if I connect directly, so it gives a problem, the system may collapse. Okay, so like that, this islanding problem. And one more is what normally is what we'll think that islanding means what already is what normally the staff will think that it is grid is off, but now is what because of renewable sources power is injected. So the means what that the staff who is working on that one, they may get shocked. So these are the some problems there. Now I'll hand over these grid penetration issues of solar power to my student because he is doing research on this area. So I think he will give better clarification than me. So I'll hand over to my scholar.
Good afternoon, everyone. I thank my supervisor, Professor B. Mangu sir, for giving this opportunity to share topics on grid penetration issues of solar PV power. And also thank the management of St. Peter's Engineering College for the same. As sir told, understanding the issues is very important to carry on the research and understanding the topics thoroughly. So here I am to share a few topics on grid penetration issues of solar PV power. Majorly when solar PV power penetration is very high. So what are the issues we generally face, and how literature, how the research is going on these issues is I will be discussing in brief. So just I will list out what are the general issues as shown on the screen. It is like poor voltage profile by and then when there is a bypassing load through the solar plant, etc. Then there will be a shading, and then there is a mismatch in the power. Then the third one is like stability of the system. When we go on injecting solar PV power, the stability of the system may not be uh, there may not be as same as the earlier conventional system. So then there is a lot of sir told that these renewable energy sources are very intermittent in nature. So there is a lot of active power variation because of this because of change in insulation and passing loads. And nowadays you can see since 3 days there is no solar PV power also. And then reactive power flow in the line, because earlier in a conventional system the power is used to flow from source to load, but now we are injecting power at the load point at the load point. So that's why we call it a distribution generation. Sometimes the power will flow towards the source, conventional source also. Therefore there is a power flow in both the directions. So similarly there is a reactive power flow in both the directions. Therefore, because of this issue, because of this phenomenon, there are certain issues are being highlighted because of this PV penetration. Next, less utilization of PV inverter. Nothing but when we go for a solar, it will be available only in the daytime. But in the night time, we can there is no solar power. Therefore, we are not able to utilize the inverter which is present in the system. Therefore, this is called less utilization of PV inverter. However, with the battery systems, if we connect a battery to that in the night time also, we can use the inverter, but not up to the mark. Next, islanding problem. As sir told, there is a issue with the islanding problem. Islanding problem in the sense when both two sources, when a conventional source and a PV source is available, and the grid is disconnected, but solar is not connected. The lineman who is working in the system may not able to find this problem, and he may get shocked. This is called islanding problem. So when we install a PV, renewable energy source, along with the conventional grid, we need to solve this islanding problem, and then we have to implement. We have to. Therefore, next is leakage currents, both at PV panels and inverters. So there is always a leakage current because of that voltage at the inverter. Generally, it depends on the voltage at the inverter will depends upon the topology what we are using, inverter topology what we are using. Based on that, the leakage currents will generate. So and there is always some capacitance existing between the PV panels, because PV panels are like metallic panels, and earth you have between those two there is a air gap, and that air gap will form a capacitance which allow the current, the leakage current to flow through from panel to the ground. So these are so you have some leakage current, therefore the efficiency of the system will be reduced. And moreover, when harmonics are introduced because of the because we have some power processing, we need to switch on switch off the switches in the inverters, and we are using MPPT technique, which is done with the help of a boost converter. Then we are using on-off method, except because of all this, some harmonics are induced in the system. And then later, the last one is LVRT. LVRT, sometimes low voltage ride through capability. We can also call the other word is like fault ride through capability. These two capabilities has to be implemented in the inverters. If not, again, when there is a fault, there is a disconnection of the PV. When there is disconnection of the PV, again the active power balance is not, the power is the net power in the system is reduced. Therefore, again the frequency regulation frequency problem issue will be developed. So all this I will just explain in just I will show the slides. Say poor voltage profile in the sense. So now we are injecting solar power between the conventional source and the load. Therefore, the voltage power, generally the voltage profile from the source to load will be decreasing in a conventional system. But whereas here now the voltage profile is not constant throughout the feeder length, because we know the voltage V is proportional to Q P minus JQ. Therefore, when the power is flowing in the reverse direction, it becomes P plus JQ. Therefore, the voltage will be increased as we move along the length of the feeder. Moreover, when we go for higher penetration, see for example, at 60% of penetration, the voltage profile is like more than 1 unit. So the standard is like 1 unit only, but in all these cases, the voltage levels are high. So these are the one more issue. So here I mentioned, as we move away from the source along the length, the voltage profile changes, which is not same to the conventional system. What happens, from source to load, the voltage will be falling, and that's why we use some boost transformers, etc., to maintain the voltage at the load end. But this is not the same case with the solar, when we inject solar PV power in the system. Partial shading. So see here in this, you can see there is if you go for a 100 megawatt plant, there is a big array of solar panels. So sometimes one cloud can cover a certain array. Therefore, the power in this, the voltage in this is not same as the voltage in the second string. Therefore, this is called a power mismatch. So when we have a power mismatch, because of the shading, the MPP point will be changing. So maximum power point tracking, what I told, where we have to utilize more power, we have to utilize whatever available power from the panels is missing. Therefore, if we want to use that power, again there should be change in the control strategy to extract the maximum power when we have such kind of a passing cloud. So the power output is of string or module. The reduced power has to be supplied by the conventional generators also. Whenever there is a reduced active power in the system, again your conventional generator has to be identified, and you have to inject that same amount of power by the conventional generators, because we need to meet the load. That is our main target. So poor dynamic stability. So this is a major area what I am working here. So the stability of the system will be not same as with the conventional system, because in a PV system there is no inertia, because there are no rotating parts. Therefore, this is when they have a less inertia, therefore, then according to our principles, when we have a sudden disturbance in the system, if when we have a inertia, what inertia is nothing but inertia is nothing but a property of a system. It is reluctant to the sudden change is called inertia. So that is what inertia. So when we have a sudden disturbance in a conventional system, the conventional system doesn't come into picture, doesn't react to the disturbance. Whereas in a PV system, as there is no inertia, when there is a like LG fault, when you have LG fault, suddenly the voltage falls in a PV system. But in a conventional system, the voltage doesn't fall, because the extra power which is necessary is present in the rotating parts. That power is utilized by the conventional system, but it is not happening. Moreover, if you see a equation here, the inertia of a system is like HSI is proportional to the product of individual inertia into apparent power by the summation of the apparent power. So what happens? This HI for a PV inverter system is very less. You can neglect it. Therefore, the numerator will be less. When the numerator is less, but we are adding all the apparent powers here. Therefore, the net inertia of the system will be less. So when this inertia constant is less, what happens to the dF by dt? There, what is dF by dt? The rate of fall of frequency when we have a delta P in the sense when there is a power mismatch. So when there is a power mismatch in the system, what happens to the rate of fall of frequency? It depends on the inertia of the system. So when we go for a PV inverter system, this the entire inertia of the system is very less compared to the conventional system. Therefore, for a small disturbance also, the rate of fall of frequency is more. In the sense we know, in the sense, according to grid standards, when the frequency fall is like 47.5 hertz, then automatically we say the system is collapsed. So we should not make the system to make the frequency of system to fall like 47.5 hertz. Below that, if you fall, no, the entire system will be collapsed. And this is more affecting, the rate of fall of frequency is more affecting because of this inertia less system, which is because of PV system. Okay, so based on these two equations, we can just identify that how the free inertia of a system is affecting the frequency regulation of our entire power system. So one of the major issue when we go for a higher PV penetration of solar power into the grid. I hope you understood. Say any doubts here, you can ask, because this is very important slide. So I'm continuing. So just here, this side shows what happens when there is a passing load. So majorly when there is a passing load, in the picture you can see I have shown it the net load. Net load in the sense, net load is to be supplied by the conventional source or grid. So when there is a passing load, when there is demand from when there is demand by the load, but there is a passing load, therefore the PV cannot generate, then immediately your conventional generator has to give that power. The conventional generator has not giving that power, the conventional grid is not giving the power, and therefore again there is a frequency, there is a fall of frequency. We know that when there is a power mismatch, automatically the frequency falls. That is called the frequency regulation curve. Okay, so this is the burden, this is the extra burden which is being introduced by the PV power. Therefore your conventional generator has to cope up with such kind of phenomena, and we have to be alert when you are using a PV integration, when you are going for a PV power into the system, we are injecting a PV power into the system. Okay. When there is a radiance change, therefore the net load is coming into picture. Reactive power flows. So PV source can only deliver active power, but therefore as a PV penetration, so therefore PV is an active source. I mean, the DC source we can call, because we have shown in that also it is a DC model. Straight current is not an alternating current. Therefore delivers only active power. But in a system, generally in a power system, we require reactive power. So the reactive power to maintain the stability. Here the only thing is you need to, since the PV source is a DC source, and then your system load is demanding reactive power, so the only interfacing equipment is like inverter. So with the help of inverter, we need to inject reactive power. So how we can inject reactive power? In the sense, by changing the phase angle between the voltage of the PV inverter and this, you can also change the reactive power. And by also I also told that when there is a change in the magnitudes of the voltages, we can also inject reactive power into the system by this. But the problem is that what I identify is already we have introduced many inverters into the system right now. For example, 33 gigawatt of solar power is being injected into the grid, and nothing but 33 gigawatt of inverters are already introduced in the system, and those are all operating at a unity power factor. I don't know whether this control method is present in that or not. We have to verify it, and later if there it is not available, then we have to introduce this parameter also in the control strategy of the inverters. So that is a bigger issue. But the peak load, generally the peak load will be in the night time, which limits the reactive power flow. Therefore additional devices have to be incorporated to maintain this reactive power in the system. That is one of the major issue which is posed by this PV injecting PV power into the system. Next, highlighting problem which Sarah discussed. This is what harmonics. So there is a small little work done how the harmonics percentage are being increased when we have 1 PV, 2 PV, when high PV. So when we go on increasing the PV power, see how the harmonics percentage are being released. Moreover, you can see the fifth harmonic is higher than the other harmonic content. So again, we have to use the fifth harmonic filter to reduce the harmonic content into the system. So the voltage harmonic decreases as the PV the penetration level increases, but not about the current. So next, fault right through capability during fault conditions. So what is this actual means? It refers to additional capability to inject reactive power during fault conditions for voltage recovery. So we have to inject what it is very important thing to inject reactive power during fault conditions like LG fault or WLG fault. Immediately when there is a fault, we should not disconnect the conventional sources. It should has to maintain for certain seconds or milliseconds to maintain the to keep the system in operation. So that capability has to be introduced by the inverters, which are used in this PV, which are used in solar PV power. So this is very much necessary for a low voltage grid integration systems. The major changes has undergone in PV control strategy. So it should change. What actually it should do is it should change. Sometimes it should change to non-MPP mode in order to avoid tripping the inverter over current production. Therefore, grid connection codes are to be changed to incorporate inverter. Already there is a lot of changes in the by the IEEE grid codes. IEEE has given 1547. They have a IEEE grid code. They have updated the grid codes for this renewable energy integration. So even IEEE to 2019 grid code also made this LVRT concept, and they have mentioning that at least 40% should be there. This capacity should be present within the inverter of the PV source. So leakage currents, I am just showing here how leakage currents will happen, where the capacitance will come into picture. Like leakage currents are due to parasitic capacitance existing between the panels and the ground, I just told. So what are these effects? Are distorting grid current. So when you are injecting grid current, no, we have some, because of these harmonics, you may not be sinusoidal. You have fifth harmonic current in that. So because of fifth harmonic current, again the reactive power will be there. And then electromagnetic interference, reduction in the safety of personnel. So the person who is handling this PV power plant has to be careful with this parasitic capacitance, because sometimes he may get shock also. So these are the some of the issues. There is a lot of literature research is going on to reduce this leakage current also. So next, I'm just concentrating. My work is on this stability point of view. Therefore, I just concentrating stability issues. So according to the statistics, by 2022, 100 gigawatt of solar PV power will be integrated into the grid. This is what government is aiming to generate 100 gigawatt of solar PV power, and it will be injecting into this. So this will be around 35% of the total generation in India. So, and then according to our National Electricity Policy 2018, some of the coal-based power plants are going to shut down. So now we can see there are the solar power is, we are injecting more solar demand power, and then simultaneously we are shutting down some of the coal-based power plants also, because they are not able to meet the standards which the government has. Okay. Even our Kottagudem power plants also, you can see in the statistics, they are going to be one or two units are going to be shut down in the future also. So according to the statistics given by the Central Electricity Authority, and retirement by 2025, around 6 gigawatts of coal-based power plants are going to be shut down. Shut down due to impact on environment is like 16 gigawatts, because environment impact means nothing but some coal-based power plants are generating more pollution what they has to be. Therefore, they are going to shut down 16 gigawatts of this coal-based power plants. And then if you take by 2027, 25 gigawatts of coal-based power plants are going to reduce. Therefore, by 2027, almost 50 gigawatts of coal-based power plants are to be getting shut down. In the sense, you are injecting more PV power. So what again, if you inject more PV power, all those issues what we have discussed, they will come into picture. So moreover, the stability issue will come into picture. So that is what I want to highlight using this slide. So just this is what actually regarding stability point of view, I just want to repeat once again how the system works, conventional system works, and relating with the PV grid system. So because of its nature, the load demand required can't be met automatically. This is due to lack of energy storage, whereas in conventional generators, the energy is stored in terms of kinetic energy. So what is kinetic energy? Half J omega square, where J is the moment of inertia. But what is actual power? We need power. When there is an increase in load, the frequency will decrease, and the the frequency will decrease, and the kinetic energy follows it. Hence, there is a rate of change of energy. Okay, so this is for kinetic energy is changing with respect to time. So how kinetic energy is changing? There is a fall. There is an increased load. So what is power? Power is energy per time. So what is power? Power is equal to initial kinetic energy minus final kinetic energy by time. This power will be equal to the increased load power. Hence, power balance is also at the cost of fall of frequency. This is happening with the conventional generators. So when there is an increase in the demand in the load, what happens? The frequency falls. When there is a frequency falls, kinetic energy changes. The rate of energy is nothing but your power, and that power is equal to the load power which we need to supply. So there is a power balance is happening in a conventional system at the cost of fall in frequency. But this is not the PV system. Later the AGS means automatic governing control comes into action, where the input to the turbine is increased, which delivers the necessary increased load demand and the frequency is maintained. So this is what step by step. There are three control: primary control, secondary control, tertiary control. These three control methods will be happening in conventional systems. But whereas this setup doesn't exist in the PV system. So instead of frequency, what is there here? The DC link voltage will decrease to give the excess demand, which results in decrease in its output voltage. So this is one of the issue. So in the conventional system, the load sharing between the units is based on the droop characteristics. But now the load sharing can't be much easy. Okay, based on our, if we go in our BTech subjects, we just draw the droop characteristic, and based on that we go for load sharing. The load sharing of two units depends on its droop characteristics. But here there are no droop characteristics in a PV system. Then how to share the load? So that is one of the issue. Since power availability PV depends on the irradiation, therefore only conventional generators has to be adjusted. So we can't. What is the meaning in the sense? So when there is a change in the load, we cannot adjust PV immediately as done by the conventional system. Therefore, again there is a burden in the conventional generator. So though they were introducing PV power, and we have to manage with the only conventional generators to balance the PV power is the major point of view. Then how to cope up these two units in a large scale? That is the issue. If you don't cope up, then again the stability will come into picture. So then let us see one of the statistics. The inertia constant. I told the inertia is major point of view, is very important parameter in maintaining stability. I have shown the equation also, and the rate of fall of frequency with respect to inertia. See, let us see what are the things. The inertia constant of some of the turbine generator, which is I think 800 RPM. So less speed nothing but hydro power plant. It is like around 9 to 6, whereas in 3000 RPM it is like 7 to 4. So, and this is available in your Potsdam book by DP Kothari. This table is available. And water wheel generator, which is having less than 200 RPM, it is like 2 to 3. And for a synchronous condenser, it is like 1.25. But if you calculate for a PV inertia in a PV system, the only inertial element is capacitance. And if you calculate the inertia of the capacitor which is used as the DC link voltage like 0.004. So very much less compared to this all these equipment. Next, time frame. What is happening in a real system? Time frame for the frequency control conventional system. So when there is a sudden increase in the load or decrease in the load, first inertial response will come into picture. Nothing but that inertia constant will play a role. So up to 0 to 5 seconds, the control will be based on inertial response. Nothing but the kinetic energy will take up the task and will maintain the power balance. After 1 to 20 seconds, the primary control and the governor will come into picture to maintain the power balance. And then up to 4 seconds to 3 minutes, the secondary automatic generation control will come into picture. Okay, so like this, you can maintain the stability of the system using in a conventional generator. You have all these control equipment to maintain the power balance. But whereas in PV system, that is not available. Moreover, in a real-time market, what happens? For every 15 minutes there will be load shedding. Okay, the regional load dispatch centers or national load dispatch centers will alert all the state load dispatch centers to give their power generation for every 15 minutes. So in this now the government you can go for the government is reducing the time duration also. For every 55 minutes now every utility has to update what is the power availability in the system. So when you take for every 5 minutes, in these 5 minutes, if there is a power balance in the system, in a conventional generator, all these are coming to picture to maintain the power balance, but that is not with a PV integration system, PV power. So this is what actually in real time, this is a problem with the PV power. So there is a power grid has done some research on this, where you can see a lot of variations in there. This is what the yellow one is like load, and their net wind, they have taken wind and solar. The green one is wind and solar. So there is a lot of variations in the renewable energy sources. and the load is almost, this is what yellow color is load. So when because of these variations, there is a more burden on the conventional generator, which is given by the net load. So see here, for example, at this point of view, there is a steep ramp up. There is a sharp increase in the power, which is to be delivered by the conventional generator. Okay, see here, there is a increase in the power demand by the load from the conventional generators. So in this point of within this duration, your conventional generator has to increase its power. So whether it is possible or not, we have to see. Similarly, at here again, the kind of renewable energy source is higher. Therefore, the necessary of power from the conventional generator is less. Again, there is a ramp down. So this burden is, there is a burden on the conventional generators because of this intermittent nature of renewable energy sources, and your power system, all the conventional generator has to be cope up with these steep ramp ups and ramp downs. So that is a bigger issue. So that's what the same figure has been shown in this table. In the phase 1, what typed it is a ramp down. It is during from morning 7:11 to 11 a.m. mainly due to rising solar energy is rising. Therefore, there is a ramp down of conventional generator during this time. In phase 2, what happens 4 to 6 p.m. mainly due to fall off in solar generation, and there is a ramp up. Again, your conventional generator has to increase its power. And in phase 3, what happens mainly due to rise in demand. 6 to 8 p.m. there is there is increase in the demand, and your PV cannot give. Therefore, again, you have to increase the power generated by the conventional generators. So there is a lot of burden on the conventional generators and the conventional power system because of introduction of these intermittent nature sources. Okay, that's what I want to highlight. So in such situations, there may be a limit on dispatchable generating ramping rate, that how much faster it can ramp up. So we cannot increase suddenly the generation from a conventional generator. There is a, because there is a bigger, it's a very bigger unit. You have a more inertial elements. Suddenly they cannot increase. So there is a lot of burden. And if you increase suddenly also, the life of the turbines, etc., may reduce. So all these are all these are problems which you are facing by the conventional generators because of this integration. So but what is, so in the same, from the same figure, from this figure only we have taken how much percentage you have to increase. So from 7 to 11 a.m. I have to increase we have to increase 33 megawatt per minute. In 1 minute you have to increase the generation by conventional generators by 33 megawatts. Now you see, if I increase more renewable energy into the system, when you inject more renewable energy, and that ramp up is like 150 megawatts per minute. So again, if you go for 50% of renewable energy sources into the system, and this will increase. When this is increasing, whether our conventional generators are ready to maintain such kind of ramp up, we have to go into we have to check. If not, again you have to change the turbine AGC actions. We have to reduce that limits, etc. So that is happening in the real time power system. Okay, in the evening time it is like 17 gigawatts when 15% RE scenario, but whereas 30% RE scenario, you have to increase by 175 megawatts per minute, whereas in the evening time it is 275. So within 4 hours 48 gigawatts power has to be injected by the conventional generators. So that is a bigger issue, and now we are going to more and more renewable energy sources, and this ramp ups will be increased. Moreover, we are shutting down some of the coal-based conventional generators. So all these things are happening in the real-time issues. So we have to, these are the challenges posed by the renewable energy sources. So study in real-time issues is existing here. So the IEGC, Indian Electricity Grid Code, states that you can also get supplementary control for increase the recommended rate of changing of governor settings, that is supplementary control for increasing or decreasing the output generation level for all the generating units irrespective of the type and size. So they have given certain conditions, certain ramp up rates for a conventional generator. So all this should be followed by the all conventional generators, all state load dispatch centers, all state utilities like TS Genco, etc., Tamil Nadu Genco, etc. So for a coal-based power plant, the ramp up should be 1 to 2% per minute. So based on percentage means based on its ratings. If it is like a 100 megawatt unit, for example, 2% means 20, like 2 megawatt in minute. In 1 minute you have to increase up to 2 megawatt. But the supercritical power plants, the ramp up will like 300 megawatt, and nuclear power plant it is like 1 to 5% per minute. So like this. Now if you observe here, hydro storage is having more ramp up rate. So I think, but you can increase the power from these hydel power plants more easily than the solar power plants. So then the coal-based power plants and your gas combustion technology has 20 to 25%. You can increase the power, but coal-based power plants are not that much. Okay, and then earlier coal-based power plants are not supercritical power plants. Therefore, if it is supercritical power plants, it is like 3% you can increase within a minute. But earlier coal-based power plants are not like that. So therefore, they are shedding these old coal power plants. And if anything which is coming now, any coal-based power plants is like supercritical power plant because to maintain these ramp-up rates. So this I told. Next. So summary. So what I want to conclude is in the conventional jungle generation, their inertia helps to maintain transient stability. Therefore, in future, the PV power generation will play a major significant power sector. To operate along with the existing system and to maintain stability, certain changes has to be made in the operation of PV inverter. That is the issue, and we have to work on these PV inverters. The only energy storing in the PV power plant is like a DC link capacitor, may not be sufficient to maintain the transient stability in the PV grid plant operation. So these are the types of grids. So this is the major area we have been working, and there is a major challenge which is posed by this PV power when we increase its penetration level in the system. Majorly the effect is on frequency. Frequency regulation is the major issue when we go for higher PV penetration level. Then these are the types of grids. So based on the grids capacity, there is a classification in the types of grids. Standalone system we have up to 0.1 kilowatt, and then pico grid is like 1 kilowatt, and nano grid like up to 5 kilowatts. Okay, and then microgrid is up to 5 to 100 kilowatts, and mini grid is up to 0 to 1 megawatt. So nanogrids are very small, are small residential power systems with renewable sources, storage, and domestic loads. So nowadays, the government is encouraging to establish 2 to 5 kilowatts of solar power panels on the rooftops, so that you can improve the efficiency of the system. May not have connected this such kind of system may not have connected to the grid. Once you have a storage energy storage element, we can manage within our household. There is a low cost of electrician. Most viable solution for rural electrification. So when we have certain areas where we cannot take our grid power to this to their location, therefore we can go for these nano grids, and we can go for local control and optimum on scalable. Scalable in the sense we can fix its rating. Because, for example, there are 10 houses, we can justify. We can just scale it like it is to 3 kilowatts of power utilized. So based on that, we can establish nano grid. So this is what typical nano grid. So we have to change this nano grid to smart grid. So what is smart grid? We have to introduce this communication network in this grids. Therefore, the grids will change into smart grids. So this is one of the AC microgrid. Here we can change. So for DC, it is a DC, and then DC is connected to AC, and there is a AC bus line. And here we have a battery energy based storage element. We are converting DC to AC, and then we have a AC loads here. This is what a hybrid AC-DC microgrid system. So we have a AC bus. The thing is that you could just concentrate on the bus. We have AC bus. So based on this AC bus, here we have connected transformer, then AC to DC, and then we are changing to DC, and then we are using DC also. It's a bidirectional power flow is happening here. So we can go for in future we have to go for a hybrid system only, because nowadays more DC loads are coming to picture. And then we have a localized generation like PV power plants and wind energy system and biogas power plants. Therefore, a hybrid system is a good solution for the coming future. Then what is smart grid? Smart grid in the sense it stands for sustainable, manageable, agile, robust, and trusted. So it's a generalized definition. A smart grid delivers electricity from supplies to consumers using digital technology, and this is a generalized definition. So all these comes into picture. We want to change a conventional grid to a smart grid. And so what are the characteristics to be there? What are the features to be there for a smart grid? I have mentioned in this third column. And what traditional grids have the features I have shown here. So traditional grids are dumb grids. They cannot speak. Nothing but they cannot give what is happening in the other side. Whereas in a smart grid, it will give both what is happening in the load side and what is happening in the source side. Therefore, they can talk each other and they can manage themselves. Communication is a major area where which plays in a smart grid. in customer interaction is there extensive. Even a load, even the consumer can adjust his load, etc. in a smart grid, which is not there for any conventional grid. So metering has to be go for digital net metering is being introduced. So operation reliability is more in a smart grid because we can connect more number of sources. Therefore, the reliability of power will be there, and it is self-healing. So you can make it as self-healing. Whether here in traditional grid is a manual, but here we can make it as self-healing. So these are the characteristic features of a smart grid. So just shown in the picture. Generally, conventional sources you can see energy conversion devices are like there, where mechanical to electrical. Whereas in renewable energy, we have a polytronic device is there, which is helping us to connect to the grid. And if you want to go for a smart grid, you have to introduce the smart meter device, etc. And which result then how you will introduce by interfacing devices, and then give to polytronic devices. Again, here also you introduce smart meters, etc. Then the grid will convert into smart grid. So with this, how to convert into a smart grid, I have shown in this slide. And these are the various control methods are available in power electronics. So I just highlighted what are the available control methods are there to operate our power electronics, because the only inverter is there. We have only inverter to manage the entire thing, to maintain stability or to inject power, to inject reactive power, to maintain power factor in the system. So these are the 5 methods we can see in the literature. One is linear control, where you can use PI controllers, and which is designed with the help of root locus method. Then hysteresis control, this is very robust control method. And we have a fuzzy control method. It is a human interface, and because on-off method like that, you can already have to train it according to your training system. It will work. Then a sliding mode control, and then we are MPC. MP stand for model predictive control. So these are the major methods where you can use with the help of methods you can control your power electronics. So I have given some of the advantages and disadvantages of each method. Please go through it. And then I thank for everybody for listening to my my presentation. I thank Mangu sir for giving this opportunity, and also thank the college management for giving this opportunity. If there are any doubts, you can ask you.
Participants can unmute yourself and ask doubts regarding this particular lecture. Yes, sir. I think we don't have any doubts. Any doubts from participants? Okay, sir. Thank you for the wonderful lecture on these particular topics, like a grid operation of a grid, utility of a grid, and microgrid and smart grid. I'm very happy to give you a vote of thanks to Dr. Mangu sir, working in OU College of Engineering. Sir covered a few essential topics that are essential for a research scholar who is doing research in renewable energy and their integration with a smart grid. Sir covered topics like PV cell, basic topics like a PV cell, issue related to the parameters like X by R ratio, SCR ratio, and etc. And also, sir discussed with a detailed graphical relation between the power and voltage, with a change in external parameters like voltage and irradiation and temperature. And also, sir discussed IV characteristics. And then sir move on to the need for MPPT techniques, how we are going to obtain maximum power from PV cell with the help of power electronic converters. And sir discussed boost converters, and also sir discussed the challenges which are facing to charge a battery with the help of a boost converter and solar array combination. And then sir move on to the topic like a detailed explanation on with the help of algorithms and graphs. Sir discussed different MPPT techniques like perturb and observe method, hill climbing method, incremental conductance method. And then sir discussed a standalone system, the challenges which we are facing in the standalone system and the solution to those challenges. And then grid connected system, challenges we are facing in a grid connected system and solutions to those grid connected system. Then Sir Research Scholar, who is a PhD research scholar, discussed few key issues for grid penetration of a solar PV cell. The few key issues are challenges in voltage profile with a length, changes in voltage profile with the length, partial shading, poor dynamic stability, reduce in power flow, reduce in reactive power, islanding issue, and etc. These are the topics, these are the challenges which are addressed by research scholars. And then Sir Research Scholar also addressed few key issues like a PV grid integration, stability issues, and real-time issues that we are facing where there is a lack of power delivery by the renewable energy. And in the end, Sir Research Scholar gave a brief introduction on nanogrid, hybrid grid, and smart grid. I would like to thank Mangu sir once again, in spite of your busy schedule, accepting our request to talk and to deliver a lecture in this STTP. And I will thank you, sir.
Thank you, sir. Thank you so much. Thank
Yes.
you. Thank you, Brahma sir, and all the participants. If you have any queries, so please, I will share my mail ID also.
Yes.
So please go through the slide. If you have any doubt, please contact me or my scholar. Thank you,
Yes.
sir. Thank you so much.
Okay, sir. So I request all the participants to join the session at 2 p.m. To join the session, second session of this day, which is starts at 2 p.m. by Raviteja sir. Okay. Here I conclude the session. Thank you, everyone.
10 నిమిషాల ముందే వస్తా ఉంటారు ఆయన. ఉండు తృతీయ